Okay, so this is a question 7. It's an alternating current question. And you are basically passing an alternating current through the resistor. But this current is a very strange rectangle wave current that goes from negative to positive 2, -1 to positive 2 at alternating intervals. So determine the expression in terms of I0 and R for the power dissipated for the times where the current is in the negative direction. P is equal to I square R. But in this case, it's negative I0 square R. So this will be I0 square R. Just like in the positive direction, P will be equal to 2 I0 square R, which will be 4 I0 square R. Nice. If you don't remember the I square R equation, then a bit sad. Okay, B, sketch the variation with P between 0 and 2t. Label the power axis with an appropriate scale. Okay, so there's no unit, but I need to plot I0 square R, 2 I0 square R. And I think I will just draw everything like if I were a student. 2 I0 square R, 3 I0 square R, 4 I0 square R. So it was I0 square R first, followed by 4. And this is easier because they are general values. So as long as the ratio is 1 to 4, then can read. Right? Scale is fine. No need to concern yourself about prefix or anything else. Okay lah, something like this. So we sketch a lot of graph already as we do this paper, which means it's a kind of important skill to have as a physics student, okay? All right, so here are the marks. If you sketch a square wave with period t and your p is never 0, 1 mark. Horizontal lines, all horizontal lines. So basically, these two, 1 mark. These two, 1 mark. With the axis, okay? Label on the axis 4 times. And then 1 mark is just for square wave of period t. So the period is correct, 1 mark. Graph is good. Explanation always harder. Graph, if you understand it, is okay. All right, determine in terms of I0 and R, the mean power in the resistor. Okay, so to find average power, I will always take the total area of the power time graph divided by the time. So the time can cancel, but this one is the time for 1 cycle, total area of power time graph for 1 cycle. Okay, so this one is I0 square R times 0.5t plus 4 I0 square R times 0.5t divided by time taken for 1 cycle t. So I'm looking for the area. I0 square R times 0.5. This one is 4 I0 square R times the horizontal axis 0.5. Okay, and I do this because then my mean power would be I0 square R plus 4 I0 square R times 0.5. The t and t will cancel off or divide by 2. So I will get 5 divided by 2, 2.5 I0 square R. This one, because it's an expression, you are allowed to write 5/2. Although I won't do it because I don't want that habit at all. I want to delete it from my system. Okay. So this one is preemptive, okay? You can divide by 2 for this one because the time for each interval is the same. But if the time interval is not the same, I've previously mentioned to you before, then you should take the total area. It's a bit like your average mark is only A plus B divided by 2 if the subject A and B has the same weightage. Meaning an A in physics is as important as an A in bio. A plus B divided by 2. Okay. But if let's say one subject got service learning, But service learning not that important. So maybe you need to divide the weightage or the ratio differently. Okay? Refer to this equation for reference. Right, finally, root mean square in the resistor. Well, mean power is Ir.m.s square times R. Mean power will be 2.5 I0 square R. I want to find Ir.m.s. The R can cancel. So Ir.m.s will be square root of 2.5. And that is square root I0. I'll poke my calculator. Mark scheme allows you to keep your answer this way, but I don't want it to be a habit. So I will still press calculator. 1.58 I0. So if you have the understanding that this one is I0 square R, it's 1 mark, this one is 1. Okay, what I think about this question is that they're laying down the groundwork for possibility for your graph not being constant, period. So maybe your graph looks like this, then like this, then like this, then like this. Okay, current IT graph. So then you have to take this entire time frame. But then you will take the pink color area and the blue color area, add them together. Of course, you need to square it first now. Okay. So the understanding is either they will do this or they will give you a similar rectangle graph, but we will not give you anything where the current is not constant. Because don't forget, we have to square. So the step here is you find I, and then you look for I square, because power involves I square. So you will get a graph like this. If let's say I give you a graph that is a straight line, but it's not constant value. Let's say for whatever reason, the current is very fancy. Current go up this way. Give you something like this. Then how? GG, oh, when you square this graph, good game, man. Your graph will look like this. Square ma, x and x squared. And have fun now looking for area. You will need to integrate already. Integration is not in syllabus for physics. So I don't anticipate a graph that has changing value. It's always a constant value that swap instantly like this type. This one's still okay. This one, you want to find area, then you need to find this area, easy. You want to find this area, integrate. But you can't integrate, so you need to count boxes. Don't do it. Okay.